think it was my fault. That's probably my fault. It's usually my fault, so I'll take the blame. All right. And okay, share sound, audio video clip. All right, now let's try this again.
Welcome to Toyota's world of advanced manufacturing. You are about to get a behind-the-scenes look at the people, processes, and US-based manufacturing facilities assembling the safe, high-quality vehicles Toyota customers know and trust. But before we do that, let's talk about how Toyota came to the US. Toyota established itself as part of America's cultural fabric over 60 years ago, when Toyota Motor Sales USA Inc. was formed in 1957. And we've been going places ever since. Toyota debuted as a US manufacturer in 1986 with the production of a white Corolla FX16 at the new United Motor Manufacturing Inc., a joint venture with General Motors. As we continue to grow in the US, our commitment remains steadfast to invest locally, assemble cars where they are sold, and give back to the communities where we operate. We can't wait to show you Toyota's manufacturing processes at 8 of our US plants. Let's begin our journey at the first US manufacturing facility to carry the Toyota name, Toyota Kentucky. In addition to being the first, having started production way back in 1988, the Georgetown manufacturing facility is also the largest Toyota plant in the world. Sitting on over 1,300 acres, this plant is 9 million square feet under roof. Here, about 10,000 incredible team members assemble 550,000 vehicles and build 600,000 engines per year. The first stop in the vehicle production process is in stamping. Huge coils of steel are delivered every day, then cut into sheets and stamped into the parts that make up the car body, such as hoods, fenders, and doors. At Toyota Kentucky, these parts could become a Camry, Avalon, or RAV4 Hybrid, all of which are assembled in the Bluegrass State. For the next process, we go down the Ohio River to southern Indiana, where Toyota broke ground on their second U.S. vehicle plant in 1996. Toyota Indiana, located in Princeton, Indiana, currently has 7,000 team members and growing, who assemble the Highlander, Highlander Hybrid, the all-hybrid Sienna, and the Sequoia in this recently updated 4.5 million square foot facility. Sparks fly as the body begins to take shape in the body weld shop. After the parts of the body are stamped, robots and team members work collaboratively to create the shell body. The fully redesigned 2021 Sienna, assembled here at Toyota Indiana, use a high-strength metal that requires innovative bonding technologies such as sealer bonds and laser welding. The quality of the laser welds is confirmed by ultrasound machines. These pictures allow us to look inside the weld and confirm that it is a good quality weld, making our vehicles rigid and strong for the customer. For the next step in our assembly process, we head south to our newest vehicle production facility in Blue Springs, Mississippi, where we'll show you how vehicles get bright and shiny. Production started at Toyota, Mississippi in the fall of 2011. Built on 1,700 acres, the 2 million square foot facility annually produces 170,000 of the world's all-time best-selling passenger car, the Toyota Corolla. After body weld, it's time for the vehicle to get its personality in the paint shop. This process is so much more than just the cool colors you see. Each vehicle spends up to 12 hours here as team members and robots work collaboratively to apply protective coating, sealant primer, paint, and clear coat. Each Toyota is available in an array of colors and trim packages, making each as unique and fun as their owners. From paint, every Toyota vehicle moves to what most people think of when picturing auto manufacturing: assembly. For this process, we will head further south to Truck Country, the great state of Texas. Toyota broke ground in San Antonio, Texas on this massive 2,000-acre campus in 2003. The 2.2 million square foot manufacturing plant sits in this thriving community and is the home of the all-new 2022 Toyota Tundra. At Toyota Texas, thousands of parts are assembled to complete the vehicle, We do this together with our 20-plus on-site suppliers who are located right here on our property. From the internal features like the airbags, instrument panels, and seats, to the external parts like the windshield and the doors. This is where the vehicle all comes together. In fact, assembly is the largest production area with the greatest number of dedicated employees of each vehicle plant. One of the most exciting parts of the assembly process is when the engine is married to the vehicle body. Toyota engines and component parts bring every Toyota to life. Let's look at how and where these critical components come together. As Toyota grew its vehicle production in the United States, the need for quality engines and their components grew too. The 4-unit plants in the Toyota USA manufacturing operations are in and around areas where Toyota's USA vehicle production facilities are located, in order to quickly and effectively provide vital parts for Toyota's vehicles. Toyota Missouri, located in Troy, Missouri, opened in 1993. Its 900 team members make cylinder heads for every car, truck, and SUV Toyota makes in North America. Cylinder heads control the mixture of fuel and air into the engine and the exhaust from the engine. At Toyota, we believe the goal of reducing carbon in the atmosphere is a priority shared by all. Toyota Missouri produces 2.3 million cylinder heads per year, all from recycled aluminum. In 2020, 74.8 million pounds of the recycled materials were used to make this vital engine component. That's over 2 billion soda cans. Right down the road in Jackson, Tennessee, 300 team members take pride in making aluminum engine blocks. Like the cylinder heads made at Toyota Missouri, these essential components are made from recycled material for every vehicle Toyota makes in North America. Toyota Tennessee also makes automatic transmission cases and housings. Without these components that provide stability and protection, the engine and the transmission would not be able to transmit the power needed to keep the vehicle moving. Toyota West Virginia, located in Buffalo, is the only manufacturer in North America to assemble engines, transmissions, and hybrid transaxles in one facility. Since 2006, Toyota West Virginia has assembled parts for Toyota and Lexus models, including many of the models in our electrified product portfolio, which includes hybrids, plug-ins, battery electrics, and hydrogen fuel cell vehicles. Toyota plans to expand to around 70 electrified models globally by 2025. At Toyota West Virginia, thanks to the 2,000 dedicated team members, a new transmission rolls off the assembly line about every 25 seconds, and a new 4-cylinder engine is built every 30 seconds. Toyota Alabama is the Toyota engine capital of North America, with 1,800 highly skilled team members located in Huntsville, Alabama. Toyota Alabama produces 3,000 engines each day. Toyota sets high standards for quality, and each engine is thoroughly inspected using high-tech visualization systems to help make sure each part is assembled correctly. Once complete, the engines are sent to the vehicle plants, like Toyota Texas, to be placed in the vehicles. Let's go back to San Antonio to see it come together. At Toyota Texas, this process is called engine drop, because unlike the other vehicle production plants that install the engine into the shell body from underneath the vehicle, in Texas, the engine is gently dropped onto the frame first, before it is joined to the body. For the final step in the assembly process, we head back to where we started at Toyota, Kentucky. Toyota is known worldwide for quality vehicles. Our team members take pride in being an important part of that reputation. As vehicles head down the brightly lit final line, team members meticulously examine every inch of the vehicle with both their eyes and their hands to make sure it meets Toyota's exacting standards. With a flash of the lights and a honk of the horn, a new vehicle drives off the line. This happens at any one of the 4 vehicle production plants about every 60 to 70 seconds. If you add it up, in the time it has taken to watch this video, around 40 vehicles will have lined off. After a series of performance tests, the vehicles go to the large marshalling yards to await transport by rail or car carrier to Toyota dealerships across the country. From the dealerships, our customers will choose which model meets their mobility needs. Then, hit
All right. All right. So yes, it's a promotion video, right? It's obviously a marketing tool. They want to say, hey, we're building our cars in America, and here's how we're doing it, and here's where we're doing it. But I want you to think about a couple things that you saw in that video. First of all, what did she talk about? Well, she talked about the raw product they use. And in fact, she showed coils of steel coming in the back, actual raw steel, coils of steel, a processed steel. I used to see those steel coils leaving all the time when I was a kid. They'd be on trucks. I mean, like 24 hours a day, those things were shipping out. My brother used to proudly say that, America was built on steel. He's right. He's right. America was built. The steel industry made this country what it is. It really did. Unfortunately, it's not. The steel industry is not what it used to be, but it did make this country what it is. But she talked about their locations, right? She showed how big their facilities were. She showed how many people they had employing, but then they also talked about their automation and their robotics, and they stress how they use both. We'll get into that too. She talked about the shipping. She talked about molding and casting. And I mean, and all this stuff was in there that we're going to hit on today. And I just want to start with a video. I kind of wanted to give you an idea. Yeah, here's what we're actually talking about. We talk about production. Production does not have to, by the way, be on that level. It doesn't. Everything you see in that process is done in the kitchen, just with different product. From raw material to a production process to a finishing process, the whole 9 yards, and on a much, much, much smaller scale. It's just the way it is. It's how kitchens work. But it gives you an idea of what the process is and what we're going to be talking about today. So the video was a good start. So let's get into the lecture. So chapter 9, and we didn't do chapter 8. So we're on, if you look at your syllabus, we go to chapter 9 today. Production and operations management. I felt this is important. I really, when I went through the chapters originally, put the class together, and I looked at your course objectives, I felt this was very important. You needed to have this lecture in there. The author talks about, he gives an example of Shahid Khan, CEO of Flexingate. Well, what is Flexingate? Well, Flexingate was an after-hours auto parts store, an aftermarket auto parts store, as it would say. He was an immigrant, came from Pakistan when he was 16, got a degree in engineering, started working for them. He refined their production process and expanded their client base by selling to automakers. He eventually bought the company. Now he's worth like $7 billion. There still is a lot of money in manufacturing, guys. It's not dead. And I know there's parts of the country you can go to, like where I grew up, and it looks like it's dead. It's really not dead. It's just changed. And we're going to talk about that. All right, name that company. Locating facility is a big decision, and it is. And this company, like a lot of companies, has big facilities. This company conducted an extensive search for a second North American headquarters that entailed $5 billion in construction and 50,000 high-tech jobs. Cities across the country began a high-stakes competition. Cities were bidding. They were bidding to get this company to come in. So let me put up the poll. And it's funny because it's the same poll as last time, because I'm asking the same question, just different. Well, same poll as last time, I put that way. Who do you think it is? Which company is it? All right, come on, guys, kick in. We have 15 of you. I know there's more of you. We have more than that in class today.
Professor, what was the question?
It was about which company that a bunch of municipalities bid on recently to get them to build their facilities in their area. Which company were we talking about? All right, it's 18 of you, 19, got it. All right, let me end the poll. Share the results, there you go. Those of you who guessed Amazon guessed correctly. One of the areas was Northern Virginia. and it ended up being in Arlington, and they are in they have built their building. They're not quite finished with it yet, but it's in Crystal City in Arlington. Starbucks was a good guess. Google was a very good guess too. It could have been either one of them. Bank of America, no way. But it was Amazon, and it brought a lot of jobs to the area. It really did. It made a lot of publicity. I don't know if you guys remember a couple years ago, it was all over the news. It really was. All right. Let's get back in the thing here. All right, good job with that. All right. So manufacturing and services, in a perspective of it, manufacturing in the U.S. is not what it used to be. It used to be the backbone of the country, and that has changed. By 1979, nearly 20 million people worked in manufacturing. It was huge. A lot of this was the steel industry, but it was also the auto industry and a bunch of others. Approximately 12.8 million people worked in the manufacturing by 2019. That's quite a drop. All right, that's not 50%, but that's like a 40% drop. However, the value of the products we make the products have a higher value. So we're making less things, but they're worth more. Technology and automation we'll talk about throughout this lecture. And yes, they did change the kind of jobs that manufacturing has. They also changed the amount of jobs that there are in manufacturing. And now 80% of jobs are in the service sector. We made, starting in the 1980s, because you notice that top bullet point, 20 million people worked in manufacturing at 79. It was still the king. During the 80s, it started to transition to service and IT and those sorts of things. A lot of your IT jobs are service jobs. So it didn't leave, it just changed, it moved. Manufacturers and service organizations, they became more competitive. US manufacturers compete with China, Germany, South Korea, India. In fact, those countries, a lot of people blame those countries when the manufacturing jobs started falling off. And in some ways they were correct. It wasn't the whole reason, but it was definitely a part of it. US businesses, they have to keep up with production techniques, and they have to keep up with the way to do things. And most of that requires automation, by the way, which we'll talk about. The service industries are different. They provide customers with quality care and attention. It's not about giving them an actual product. They maintain a close relationship with the suppliers, and they practice continuous improvement. It's easier to do with a service than it is with a product when you're dealing with a production line. So what is still made in the US? Well, the top still thing is still chemicals, and they include pharmaceuticals, and we're talking about that. Cosmetics, soaps as well, paints, fertilizers, all those are massively produced in the US. Computers and electronics are the second biggest here. That's huge in this. And the other one, and I'm actually surprised this is number 2, and if you look at it, it's not number 2 by much, is your processed food, beverages, and tobacco. We make a lot of food products, a lot of beverages, a lot of tobacco. And we've touched on this before. We'll talk about, we run into problems with Europe. One of our biggest trading problems doesn't like buying our food. They buy our tobacco, they buy our liquor. They don't like buying our food because of additives we use and GMOs and stuff like that. We'll get into that further down the road in the course. Transportation equipment is the next one. The US still produces a lot of cars, trains, and ships. And I'll tell you what, trucks should be on that list. I don't know why. I'm sure it's in the category, but I'm like, when I go to Europe and I see trucks driving around Europe, like everyday pickup trucks, most of them are Fords or Chevys. I was kind of surprised. Everyone over there, they like owning US trucks. It was kind of neat. We still have our massive manufacturers, and we still have massive manufacturers. Yes, General Electric is the big one. Aerospace and engineering and energy are their 2 big things. Whirlpool was number 2, which I found kind of interesting. Broadcom after that, Emerson, Wesco, Rockwell, and it goes on down and on. I mean, so we still have big manufacturing in this country, but look at this list. I don't see any steel companies there. And 40 years ago, half of that list would have been steel companies. The way we made steel changed. Automation for how steel was made changed, and it took away a lot of jobs. Steel mills are smaller now, and they're kind of like boutique. They're smaller, and they do 1 or 2 processes instead of doing everything for everybody. They also don't make steel from ore anymore. Steel is now made from scrap steel, and I've mentioned that in the class before. And the process is easier and not as involved. And because of the automation, they don't have to hire 12,000 people. A steel mill can be run with 600 or 800 people now. So it's a lot different. A lot of things changed. It wasn't just competition with other countries. It wasn't any kind of a lot of the or there could have been political bills passed to help, but it wasn't politics. It was mainly automation. Unions didn't help either, to be honest with you. I am pro-union, but they didn't help, not with that situation. So from production, we go to operations management. Production is the creation of finished goods and services. Whatever you're selling, production is when you put it all together. Land, labor, capital, entrepreneurship, and knowledge are all used to produce. We're going to talk about that in a minute. Production management are the activities we have to do to make for the firms to create their goods. So whether it is a service or an actual product, it doesn't matter. You have to have production management. Operations management. This is what, guys, this is where I spent my career. This is what I did. It's an area of management that transforms resources, mainly human resources in a lot of ways, into goods and services. I ran, giant restaurant operations. This is what we did, right? We took raw product in the back and we transported it into edible food and we sold it. We packaged it and sold it right there. When I say package it, I meant we put it on a plate. That is actually a form of packaging. That whole list of things there, inventory management, quality control, production scheduling, follow-up services, that's what I did my whole career. Operations management is a big part of business, and it's a big part of production. And what I did in restaurants, that's only part of what I did, by the way. What I did in restaurants, other guys do in manufacturing firms, right? And in service firms, they do the exact same things. In the service sector, though, there are some nuances, all right? There are some differences. It's about creating an experience. I often would ask my staff, what do we sell? And they would, you would always get the food. We sell food. We do this in training classes. Yes, we sell food, but food is only part of it. We sell an experience at a restaurant. A hotel sells an experience. A casino sells an experience. A cruise ship sells an experience. That's all part of service. That's part of the service sector. So it's not just about, oh, here's a good product. It's a great experience, which is actually in many ways harder to do. But, you have to innovate constantly for ever-changing customer needs. And he talked about robots and AI. Yeah, especially AI, artificial intelligence. That's all part of it. Operations management allows companies to turn their ideas into actual goods and services. That's what operation managers do. We develop menus and we develop the recipes that go into the products on the menus. And we try different plates, bringing them out and serving them in different ways and on different plates and in different bowls and all this stuff. Why? Because we're trying to create a beautiful experience for the guest. That's what in the service sector, that's what operations management does. Service robots. I love this. Companies are always looking for new ways, right? To get rid of human labor, unfortunately. And I love this. It was a robot waiter. He's delivering pasta in the first restaurant in Italy to use automated servers. Who would you rather have a food served you by a robot or by a human? What do you guys think? Just chime in on the chat. What would you rather have? A robot or a human? Give me some feedback here. Look at all these different ones. Getting a lot of robots, getting a lot of humans. Human preferably, yeah. I look at all these robot, human, robot, human. It's really back and forth. You know what? The robot would be fun, wouldn't it? The robot. I'm going to tell you what I think the answer actually is to the question, and it's almost a rhetorical question, but I don't think a robot would be the same friendly experience. Yes, Susan, you hit the nail on the head. This is what I was just about to talk about. What kind of experience are you getting from a robot? Now, it also depends on what your concept is, right? What is your concept? I think if you were a kid's restaurant, robots, great. They'd love a robot coming out. But if you're fine dining, you want a robot bringing no. And you can't interact with a robot. Can the robot answer my questions? Can a robot fix something if I don't want it in a way that's not cold and mechanical? I mean, so I think there's pluses and minuses. I personally want the waiter. But I can picture a restaurant concept where the robot would be very functional and create a great experience. What if you're doing like a futuristic or you're a sci-fi type of theme or something like that? It had to be something quirky. Or like I said, if you had kids, if you're using this for kids, I think kids would love it if a robot came to the table. I know my nephews would, and they're older. Their kids would love it. I have my nieces. I have 4 nieces that are all teen or preteen. One's in college, and they would probably get a kick out of it. They would probably enjoy it. But again, it's kind of unique. It's kind of quirky. I don't know if it's something. This is obviously a pasta place. I don't know if this is something I would want on a regular basis. But I like the way you guys went back and forth, and I didn't count them. I didn't want to do a poll. I just want to kind of throw that out there. But I'm thinking it looked like it was almost even, right? What you guys are saying between human and robot. And I can see the points, right? You can make an argument for either one. So what we got? How has manufacturing changed in the U.S.? Well, it went from 20 million jobs in 1979 to 12.8 million jobs in 2019. My guess is it's probably dropped even further. However, the value of the goods we produce have increased. That's because of the technology bent mainly, right? Making steel and making computers are 2 different things. What must American companies do to maintain competitive? They have to keep up with the latest production techniques. And a lot of this is automation, and automation can also kill jobs. So there's a fine line there. I noticed in the video, she kept pointing that out. Yeah, we have high-end automation. Oh, that works with our workers. And then she would say how many, they had a lot of workers. I think a Kentucky plant had 10,000 workers or something. That's wonderful. How does operations management differ from manufacturing and service? Well, in manufacturing, you take raw material, you use human resources, parts, supplies, tools, that type of thing, and you turn it into a product, or as he says, a good. In service, you're creating an experience. You may be taking raw product, because a kitchen in a restaurant does that, but you're creating an experience is what you're doing. So I think this is where I want to take a break. All right, guys. Screen has stopped sharing. That's fine. All right. It is, let me pause the recording. One thing about it. All right. So what were we talking about? Oh, that's right. Manufacturing. Well, let's get some more into the process here. All right. So the production process. Well, when you're actually producing something, what are you doing? It adds value or brings utility to the materials you buy. So in my world, you bought tomatoes, you can make tomato sauce. That's adding value and utility through the process. There are different parts of this. Form utility. The value producers add to materials in their creation of finished goods and services. How it appears, how it looks at the end. Process manufacturing, that's the part of the process that physically or chemically changes the materials. So that's where you're taking it, like you're stewing your tomatoes, okay? That would be part of the process manufacturing. Assembly process is the part where you put everything together. You take the components, you put it together. In my world, in the kitchen, you'll be adding spices and other things to the sauce to get it to where you want it. You would be assembling it. In the automotive world, from the video we saw, it's when they were building the engine blocks and all that. That would be the assembly process. So there's an example of form utility. Now, first time I saw this, I'm like, that cake is crooked. Well, that cake's supposed to be crooked. I can tell by looking at it now, it's actually designed that way. But the baker adds form utility by transforming the ingredients. He takes milk and flour and sugar, and he makes a cake. But there's form utility, even though that's an odd form. I'm thinking this is a kid's cake. It looks kind of fun. But there's an assembly process there too, because that cake is a layer cake. You had to make cakes and put them on top of each other to make that cake. So that cake is layered. So there was an assembly process, and it's showing form. So it's a great example of both. In the production process, you start out with your inputs, and your inputs are very basic. Your land, your labor, your capital, which isn't just money, that includes any raw materials you're using as well, because raw materials count as money. Entrepreneurship, creativity, if you would, and knowledge. You take those things and you start controlling your production, planning, routing, scheduling, dispatching, the follow-up that's needed, because any kind of a production process needs to be evaluated as it goes in order for improvement. And your output, whether it's goods or services or ideas, it depends on, what you're doing. So again, when we talk about production process, we're not just talking about making something. We're talking about services as well. He says planning, routing, scheduling, and other activities are means to accomplish the objective, the output. The output can be any one of those three things: goods, services, or ideas as well. Grows basic production requirements. God, I remember these from years ago. To build and deliver products in response to the demands of the customer at the scheduled delivery time. This is where you're getting into project management big time, right? It has to be set up to come out at a scheduled delivery time, because when you're making something, when our steel mill was producing steel, there were manufacturers waiting to receive that steel. They had ordered it in advance and they needed it. And they needed it on a certain deadline in order for them to make their cars or their trucks or boats or buildings or whatever it is they were making. To provide an acceptable quality level, which is why you evaluate. We're not going to get into Edward Deming in this, but Edward Deming was the king of the evaluation process, evaluating the whole production process and incrementally making it better every time you evaluated it. To provide everything at the lowest possible cost. Your customers, just like any other customers, want the best product for the lowest possible price to them, which would be your cost, and it was how you would develop your price. There's different types of production process. When I was a kid, the steel mill had a continuous production process. It never shut down. It was continuously putting out steel. I don't care if it was 4 o'clock in the afternoon or 4 o'clock in the morning. The man worked what they called turns, which were different shifts. My father got to a point where he didn't have to work the night shifts anymore. But when I was a young man, a little boy, he did have to work the night shift still. Manufacturing like that is 24 hours a day. It doesn't stop. It's a continuous process. And back then, the demand for steel was so high that, it had to run that way. You're talking in the 60s and 70s here. The intermittent process, the production is short, and the machines are changed frequently to make different parts. So you may stop the process, change out the machine so it can do something else on the line. The need to improve production techniques and cut costs is huge. You want high quality goods and services in response to your customers' demand. You have a reputation, more than likely. You have a brand name. You have to keep that up as well. Technology and process developments have made U.S. companies more competitive in a lot of ways. In actually a whole lot of ways. They are more competitive. People worry about the number of manufacturing jobs. Manufacturing is, I don't think I mentioned this at the beginning, I meant to. Manufacturing is now only 15% of our GDP, our gross domestic product. Services are like 80%. All those other things we saw on the list is like 80%, services and technology. Manufacturing itself, it's only 15% of our economy. Not that that's not still important. It is still important, but it's not what it used to be. Computer-aided design and manufacturing. Computer-aided design falls into three different ways. One is where you use computers to actually design the product. And this is done very frequently. They use computers in the original process to figure out the product, what it's going to look like, how they're going to make it. Computer-aided manufacturing is the use of computers in manufacturing of products. So the computers are actually running the machines. My dad used to do what they call rolling tin, and he had a crew of about 5 or 8 guys, and they would process the tin. Tin has to be treated in a certain way to become tin. They would treat it and then roll it so it could be shipped out. Not only are all those guys' jobs gone, I would guess my dad's job is probably gone too. There's probably computers and robots that do that entire process. So where you had, like 8 guys on a line and you had about 10 lines going, plus a guy running it, where you had 80 or 90 people doing this. Now you probably have maybe 1 or 2, just monitoring the whole process. So it's really changed. And that brings us to computer integrated manufacturing, which is the combination of the other two, the CAD, the computer aided design, and computer aided manufacturing. It's a united of them both to do this. And I'm not going to beat around the bush. This does eliminate jobs. It makes the process better. It makes it more efficient. It brings down the cost. But there's areas in the country now people can't afford to buy anything, and that's really hurting. So there is always, anytime you talk manufacturing, there's going to be always that argument on the labor side. And he says in that last bullet point, CIM is expensive, but it drastically reduces time needed to program machines and increase production. So it's probably expensive up front. It probably pays for itself within a year or two. Things like that usually do. Flexible manufacturing, designing machines to do multiple tasks, right? So machine can do one thing, you flip a couple switches, it can do something else. This can be very, very, very helpful on a production line where you want to use the production line to make one thing, then you want to stop and have some time on the production line to make another thing. And all you do is do some switches on the machines and bang, they're capable of doing something else. Pretty advanced stuff, to be honest with you. Allen Bradley uses flexible manufacturing to build their motor starters. They build motor starters, and to make the different parts, they just flip some switches on the machines, and the machines can do a different job. It's pretty amazing. Machines and robots build, test, and package parts. They do everything now. They really do. If my father were still with us, he'd be very angry about that. He never liked the automation, well, because he was a union guy and it took away jobs. I mean, I get it. Lean manufacturing's been around for a long time. The production of goods using less of everything compared to mass production. Lean manufacturing is a great idea, and as we talk about it, you'll probably think to yourself, why doesn't every company do this? Because it can be, switching to a lean manufacturing can be hard to do. Compared to other manufacturers, it takes less human effort. It's very much of it's automated. There's less manufacturing space because you're trying to build everything down as small as you can. It requires less investment in tools. It requires less engineering time to develop a new product. So you have to have a product that's easy to make and that it is not very complicated. And you try to make the process as lean as possible. Why? So you can get it out fast, get it out quick, and get out easy and cheap. And that's what they're looking to do. Not cheap as in not quality, but cheap as in a good price, a good cost. Lean manufacturing, I think, came around like in the 80s. And there are companies that switch to it. You have to really change your whole production process, and it doesn't work for every product either. So you run into those types of things. Mass customization, tailoring your products to the needs of the customers on a massive level. All right. More manufacturers are learning to customize. There are auto companies out there that make custom automobiles. There are motorcycle companies that make custom motorcycles. There are companies out there that make custom shirts. And custom pants. And I remember my dad, first time he got a custom made golf club, it was a driver. And this is before the internet. This is way before the internet. He did it. He found something in Golf Digest, and he took all these measurements of his arms and everything, and he took measurements of his swing and all that. It was amazing. And he said, and they made him a club. It took months. Nowadays, it wouldn't take months. You just go to a golf place and they'll do it for you. They'll take pictures of you, and it's much more technical and probably better process now, but they didn't have that back then. And he was so excited. The club came in and he loved it. He loved it because it was custom designed to him. It's harder to do. To do it on a large scale is very hard. But if you have a group of customers that are willing to pay, it's probably worth it. Robotics plays into all this. Robotics allows manufacturing to work 24 hours a day. Well, you can work 24 hours a day. You can schedule people on shifts, but robots don't get tired. They work 24 hours a day, 7 days a week, and they don't ask for more pay, and they don't want time off, and they don't want to go home to their kids. And I mean, it's, they're robots. Robotics have improved productivity while reducing the number of jobs. I've been going to that. It's a touchy subject, and it's something you have to think about anytime you're going to employ more automation nowadays into your manufacturing process. How many jobs is this going to cost us? And part of that you have to start thinking about your PR, your public relations, because some news agency is going to jump on it. Well, they brought in new equipment and they cut 1,100 jobs. Well, if it's a small community, even if it's a big community, that's a big. But if it's a small community, that can be devastating. So there's a little touch and go there nowadays when it comes to robotics. But you have robotics in everything. Service businesses, hotels as well, have robotics of some type. If you go down to, some of them have, robotics now with the hotels in the laundry production because they do so much laundry. But the robots can do so much. You still have to have the housekeepers to take it upstairs and put it on the beds and all that. We may have robots serving pasta, but I haven't seen a robot clean a hotel room yet. I'm sure it's coming. Okay, 3D printing. These things are great. I love these things. They're created one layer at a time by a nozzle. It basically shoots out plastic, liquid plastic that hardens. You use molds. You come up with molds. I have a buddy of mine who's really into this. He has a robot he's been building for years. He has that. He's kind of a fun, geeky guy. And he also made himself an Iron Man costume. I mean, an entire Iron Man costume. And it looks authentic. And he used a 3D printer to make it. So when we have charity functions, I'm like, hey, Brian, can you come up and you'll show up as Iron Man. And the kids love it. They absolutely love it. But it is revolutionizing production. The 3D printer is. Just, layer by layer, and you can make almost anything with it. They're pretty amazing. Using sensing, measurement, and process control, sure. Sensors can detect a moment something goes wrong. A sensor can detect something and shut down a process before there's damage done, which saves companies thousands and thousands of dollars. And nano manufacturing, they're manipulating materials at the molecular and atomic level. And that's really just starting, but they're getting there with it. And it's starting to work its way into regular manufacturing, especially with chemical produced things like soaps and shampoos and stuff like that. They're really getting down to the nitty gritty with it. I mean, these things are sensoring's been around for a while, but nano manufacturing is going to really revolutionize the entire process. So, we talked about form utility earlier. Well, it's the value producers added materials and the creation of the finished product or surface. When a company transforms raw steel into an automobile, and we will define, differentiate the different manufacturing processes. We talked about process manufacturing, physically or chemically changes the materials, like turning sand into glass or into computer chips, making tomatoes into tomato sauce, as I said. The assembly process is where you put things together to create the product. When cars are made through an assembly line, the frame, the engine, all the different parts. Continuing process involves long production that turn out goods over a long period of time. A plant that makes plastic cups is run on continuous process. Probably mostly, I'm sure they have people working shifts, but probably mostly with robotics. Rather than using long runs, an intermittent process involves short runs that respond directly to customers' orders. So intermittent process are where you can shut things down, probably change some switches on the machine and get them going again to do something else. He does an example of this process would include manufacturers of men's custom business suits, changing it a little bit each time so the machine's making a different suit. What do you call the integration of CAD and CAM? Well, it's CIM, guys. Computer integrated manufacturing. That's where the computers are doing the design or helping with the design, and they're also helping with the manufacturing process. So they're doing both. And by the way, kind of the way that it's done nowadays, kind of the way that it's done. And what is mass customization? We just talked about that. Tailoring products on a massive level to meet the needs of your customer. And he gives a great example of Nike, of this process, Nike ID, which allows customers to design athletic shoes by choosing a variety of colors and designs. So you're kind of doing your own athletic shoes. All right, let's cut out of the PowerPoint.